Hey, so let's begin and start this tutorial. So the first step is to create the specimen component. So you want to go to Part 1, 2D planar, leave the settings as it is, click Continue. You want to draw the rectangle, so click that tool, enter 0, 0 on the end right here, and then 12.5, and then 25.1, because we have a 0.1 millimeter cohesive layer. Zoom in, and click the Create Lines tool, select the midpoint, select the point tool, and then start creating the lines. So we want to create two vertical lines, and click the dimension tool and say that it's 0.05 millimeters away, same for the bottom. Awesome. Click this tool right here, go to end. And then you want to dimension it from here to here, 0.25, and from here to here, 0.25. And then remove these lines because you have to extrude it. And also go in here again, but this time you want to delete these lines as well. And the reason is because you want one line going through, because you're making one cohesive layer. Click Done. Now we have to partition this sketch to make the cohesive layer. So click Partition Face Sketch, and then select Create Lines tool, select the top point, and then go to the end. Make sure it's horizontal. You want to do that. Do the same thing on this end here. Make sure it's also horizontal. And then click Done. So that's it for geometry. Now you want to create a property, and the material properties that we're going to be using are the following. So click Material, name it Rubber, Mechanical, and you want to do Hyper Elastic. New hook model, coefficients using are 1.16 and 10.474. So that's it for the rubber. 1.16, sorry. And then we're going to create another component. It's called cohesive. Mechanical, elastic, but we're going to click traction. The properties we're going to use here is 67.5 for all three of them. 67.5, 67.5. Then the next option you want to choose is mechanical. You want to search for max damage. In this case, you want to do 6.75 for nominal stress and 1 e to the 6 for the other directions. Sub options, damage evolution, energy, and we'll put in a fracture energy as 3.7. Okay, and that's it. Now you want to create the section. Let's call it rubber, solid, homogeneous, continue, material, rubber. Okay. Another property will be cohesive, but go to other, click cohesive, continue, material, cohesive, response, traction separation, click OK. Now you want to assign the section. So assign its top two as the rubber material, and select bottom, the middle layer, as the cohesive section. So that's it for property. Now go to assembly, click create instance, OK, and then go to step, and then create step. And we're doing static general. Now it's important to turn on nonlinear geometry because we're using cohesive elements. And then for automatic stabilization, you want to turn it to be specified dissipated energy fraction. And the value that we're using are 0.001 and then 0.05. So that's it. And then for max incrementation, just put it as 10,000. Initial increment size will be 1 e to negative 5. Minimum will be 1 e to negative 15. Maximum will be 0.1. And leave other the way it is, and that's it for the step size. Now, let's create the field output. Click OK. We want to select stress and variance. That's one thing that we want. Then we want to select total strain components, displacement and rotation, reaction forces, and then you want to go down, state, field per time. You want to make sure you select status. This will help you show when the cohesive elements fail. Whole model, every n increments, and click OK. And then for the history output, you just want to select energy. Click OK. Next up is create boundary conditions. So you want to create boundary condition. Just name it as roller. Select displacement and rotation. OK. Bottom component. And select U2 to be equal to 0. And then create another one, call it fixed. You want to select this point right at the edge right here. And select U1 and U2 to 0. This is to prevent rigid body motion. Click OK. Now for the top component right here, we'll create another one called displacement. Click continue. Top edge right here. Since we don't know how far it has to get pulled for it to fail, we're just going to guess 50 millimeters. 50. That's it for loading. Now for mesh, go to the mesh panel, click on part, and then we have to make sure that we turn this mesh here into a structured mesh. So go to mesh controls, and then you want to select everything. Click done, click quad, and click structure, and now it should be green. Done. And what we want to do is C part, you want to see it to be 0.25 millimeters. Click OK. And you see that it sees everything. Click done and mesh. And then what you want to do is that you want to assign element type. So assign the top section and the bottom section. Click done. And then you want to go down, plane stress. And you want to turn on hourglass control and make it enhanced. Click OK. And then the next section will be the cohesive layer. Select that, click done, and you want to find cohesive, and then you want to specify viscosity to be 0.002. 0.002. Yep. And then click OK. And that's it. So that's it for mesh. So now we have fully set up our model. And now all we have to do is run it. So go to job, create job, call this cohesive run. Doesn't matter. Click OK. Then click submit. as you can see, monitor it. This is what it's currently doing. So it looks like our component has finished running. Go to results on this, and you want to plot just the max in-plane principal stress, and then run animate time history. Awesome. By the way, ABAQUS sucks in terms of this contour plot. If you want to increase it, you want to go viewport annotation options. If you want to show compass, doesn't matter. Legend, size font, make it 24. There we go. And it's running again. Yep. Hope that was helpful. If you have any questions, just let me know. Thank you for watching.